Okay, so module 3, part 2. We are still talking about AI in large systems. A well-known techniques nowadays in AI in large systems is the federated learning. Federated learning idea came when everybody was asking for privacy, and also when you have different devices distributed in different geographical places. So federated learning is just a type of machine learning that enable multiple devices or other things to collaboratively train on a shared device or a shared model of machine learning without exchanging the raw data. So there are different structures of doing the federated learning, of course. But you have, for example, one centralized model, and this centralized model uh, have the different underneath, let's say, models, and these models are exchanging information with the centralized model. This is the basic concept of federated learning. And then these models are trained, the centralized model also trained based on the exchanging data and parameters without exchanging the sensitive information, for example. So this is very important for privacy and protecting privacy and keeping the data on the user device without sending it to the centralized or to the cloud. There are many use cases for this. For example, personalized recommendation on Facebook, for example. This is a kind of federated learning, or e-commerce, or any other social media. That's very important nowadays and it's trending. In healthcare, when you have centralized or decentralized patient data, and you want to use this data without sharing the actual patient information. Financial industry also, automotive car, automotive vehicle, that's also another kind of information. So federated learning, there are different kind of workflow for federated learning. Let's say that we have the aggregation server, which is like you have the central module, like here in the top left. That is the central module, a model, and this central model, the yellow one, is a server. We call it aggregation server. Information is distributed globally on the local server. The local models are trained, and you have this global and local. Global model distribute the nodes, uh, partially trained models they have, and submit their model to the server, and then return let's say the models are returning the data for continuous learning, and then when they return the data, the central model here in the yellow one will aggregate and update the global model. There is another one, which is the peer-to-peer, in which the information is shared between the model and you don't have a centralized one. So you have each device has its own model, but also there is a protocol how to share information between other without sharing sensitive information, but only sharing the information about the model itself, like parameters and so on. So each nearby nearby device or model share the model information with the other device, and these devices are get updated. and train the local data and exchange the model basically, and then each model on a device aggregate. You have a centralized data lake also. That's another kind of training. You have this is a kind of traditional let's say, federated learning training approach. The data is acquired by the site contribute data in central data lake, and then you have the independent local training data on exchanging the data, and the centralized model develop and deploy. And then it's just like the aggregation server, but you have the data center here. So federated learning in cloud edge aggregate architecture. So the cloud edge architecture is just like the let's say aggregation server, but here you have the cloud server distribute the original global model to the edge, and the edge device require edge server. The edge device, like the any device, acquire the edge server, and then initialize the model parameter. Local model output aggregated on the edge server, nearby edge server, and then the edge server, the aggregation between the edge server and the central server is done, and then the global server, or the cloud server will aggregate all the information and update the model here. Advantage, of course, there are many advantages for the IoT environments. For example, optimization of the cloud and edge architecture, aggregation and distribution across edge and cloud, bringing the edge near to the device. That's also something. There are many applications, key technologies, for example, and like this edge aggregation, computation, offloading, and so on. So there are many applications. But also there are many challenges. Then, for example, how to deal with the outliers, and when you migrate and so on. All these are challenges. Data pipeline is used a lot during the large system AI in large systems. So basically, as you can see, the pipeline name indicate of several sequences in pipeline. So these sequences that you do, these processes that you do during the machine learning, you can put them one by one or in parallel, but still there is a pipeline of processes, of jobs to be done. And this will help to automate and systematically do these things automatically. It's a framework. There are many frameworks, of course, supporting this. For example, you need to have the data storage, pre-processing, and how to deliver the machine learning mechanism. What is the machine learning? So sometimes this involves ingesting raw data from various sources, for example. So sometimes cleaning, dealing with outliers, dealing with missing information, missing data, and all these things can be done through a pipeline in which you know that this will be repeated many times. You will get outliers, for example, all the time. So when you don't need to do these things every time you get the data, you put it in the pipeline, and when it happened, the pipeline will deal with this. So this is very important for large volume data, for example, data processing, for repeatable activities. As I said, there are many tools. of course. Apache Kafka is well known and very is used a lot in the industry nowadays. Is a distributed message system enable real-time data streaming. Also, there is Apache NIFI, the data integration platform that enables the ingestion, processing, and delivery of data from various sources to various destinations. Building data pipeline is also something can be done with Apache NIFI. Apache Storm is a distributed real-time computation system that enables scalable and fault tolerance data processing. So you can see that there are many tools. Of course, we are not going to the detail of these tools. We will use some of these tools in our labs, but there are many tools, not only Apache and other tools, but also you can see that in the cloud enabled technologies, there are integrated tools. So which tool you use for your industry or your application, it depends on what you want and what you have. So each tool has some features and drawbacks. Type of data pipeline, there are many types, of course, but there are basically two types of pipeline in the data. Either the data is streaming continuously and you need to deal with this data immediately now. So that is what we call it here. The second one is the streaming data, when the data is coming and you need to do something with this data immediately, like dealing with the outlier, for example, cleaning the data before storing, knowing the quality of the data, and so on. Other thing is that you store the data in a buffer or in a data store or whenever you use it, or wherever you store the data, and then later on you come back and take batch of the data, a window of the data, and that is the batch processing, loading a batch of the data into a repository during set of time interval. For example, you log the data for 2 hours, and each 2 hour you do the processing. So this is a batch processing. But sometimes you don't have this because the data is streaming. There's a lot of data you have to respond now. So that is the streaming data, basically. There are many architectures for the pipeline, depending on what you want, actually. The data ingestion, for example, is collecting the data into one point and various data source. Like, for example, you have image, but you have also sensor data and so on. So this data is streaming, and you have the raw data source, and that is the producer and publisher, or we call it sometimes a sender. So you can choose to extract the data only when you need, when you are ready for processing. So you ingest all this data like into the data lake or into the data store. Data transformation, that's also another thing in the data pipeline that we have, which is like, for example, the data is coming always in one type of data. For example, you use the data as a JSON, you store it as a JSON, but now you want to show the data. Of course, the JSON is a mess. You cannot show it to a normal user, so you have to transform this data to another form of data of analysis, for example. So that is the data transformation. And the data storage is very important in the pipeline architecture, which is like transforming the data in you change the data in a stored, you store it in some data repository, which is a data center, data lake, whatever. And then for later on, any stakeholder, any user will come back to this data and do some processing.